FMB on ZPU or by ZPD ratio for NMOS inverter driven through another NMOS inverter. Firstly, I am going to tell about NMOS inverter. The inverter is needed for restoring logical levels for NAND and NOR gates. It is also used for sequential and memory circuits. It requires a transistor with source connected to ground and a load resistor is connected from drain to the power supply VDD. The output is taken from the drain and the input is applied between gate and ground. This is the following diagram. As shown in figure, the operation is follows. With no current drawn from the output, the currents IDS for both transistors are equal. The depletion mode device is called pull-up and the enhancement mode device is called the pull-down transistor. Pull-up is always on, VGS is equals to 0. It is under depletion. Pull-down turns on when Vin greater than Vt. This is the following graph of the pull-up and pull-down. Next one is transfer characteristics. Vin is equals to VGS. PD transistor exceeds the PD threshold voltage. Current begins to flow. The output voltage Vout decreases and the subsequent increases in Vin will cause the PD transistor to come out of saturation and become resistive. Initially, the PU transistor is resistive as the PD turn on. The point at which Vout is equals to Vin is denoted as Vin. It can be shifted by variation of the ratio of pull-up to pull-down resistance ZPU by ZPD, where Z is determined by the length to width ratio of the transistor. Determination of pull-up to pull-down ratio ZPU by ZPD for an NMOS inverter driven by another NMOS inverter. This is the following diagram of NMOS inverter. This is the following derivation of the NMOS inverter. Finally, we need to prove this. ZPU by ZPD is equals to 4 by 1 for an inverter directly driven by an inverter.